Hey everyone, welcome to another episode of TinkChat. It's been a while.
Yeah.
We've been busy building out the content library of tinkering.com's classes and courses, and just general business things that has kept us pretty busy throughout the summertime.
Yeah.
But we have been keeping attention to the development within this 3D printing world, specifically the Olympics.
Yeah.
Because a lot of stuff happened within the Olympics, and what a lot of people don't talk about is 3D printing or advanced manufacturing's impact on the performance of the athlete. So I think that's today's topic.
Yep.
Just going through and talking about, what we identified, what some of the people covered, and what we can bring insight to within, the 3D printing space.
Yeah. So I guess to kick things off, you might not know, but there are a lot of tech contributions towards Olympics, and especially just to give athletes just a slight boost. Even every second matters, right?
Right.
Just that shaving off that 0 point something seconds would matter between a gold or a silver. So all of these people, all of these athletes are just striving, training first, and then also the equipment that can help. So during this one, it's even a bit more, I guess, weird compared to the previous Olympics, just because of the pandemic. It has delayed a lot of things. And
well, I mean, at the same time, I think it also gave some teams more time to
prep
and or get advancements.
Yeah, that is
with
true.
The technology. So.
So wearable techs, there was a lot of wearable technology that was used and to train and for end use when they're actually competing. So one of the things is that came out because of this pandemic was a 3D athlete tracking system. This relies heavily on AI, but then using all these 3D scanners and everything, you monitor the athlete's every movement, every type of breathing habits or any habits they have.
Oh, interesting.
And then afterwards, it'll be all reflected onto the computer. It's not 3D printing per se, but it's 3D scanning.
Data collection. And what they do with that data, then I'm assuming impacts the performance of the athletes, whether it be through training or... I mean, that's kind of cool. I mean, data is a lot... I think what you guys will see is data drives a lot of the optimizations they're going to do throughout, everything. Every second or every millisecond counts.
Yeah.
And so the difference between gold and silver could literally be a couple milliseconds.
Yeah.
And if you can shave that off, and if you have data to back that up to know where to shave it off or how to better train an athlete, I think that makes a lot of sense.
Yeah.
I mean, it isn't 3D printing per se, but it definitely is within this realm of like advanced manufacturing, tweaking, fine-tuning.
Yeah.
No different than what we covered that time when we were talking about the hypercars.
Yeah.
Where they used biomimicry to figure out the where it's best to shave off
the
weight,
excess weight or material,
and that's all done through computational, AI and generative design. So I attribute this kind of to the same thing.
Yeah.
But just data that drives everything else.
Yeah. So with this data, Intel actually came out with this new technology, and so it actually uses the data to replicate a 3D version of the stadium of where the athletes will be running. So with that technology, the athletes can train in this virtual space, and I'm not sure how it actually works, but they can train in this virtual stadium, and so they get a feel of it. And
do they wear AR?
That I don't know.
I mean, you gotta think about it. Image training is a big part of that. Athletics. There we go. And being in the presence of the space, I think could actually help prepare a lot of athletes for the mental side of things, right? I mean, then they knew that there wasn't going to be a lot of audience, physical people there. Yeah. So being there, training there, I mean, it makes sense.
Yeah, it helps.
Yeah.
It's just like when you're in a race, you get a feel of the track before you actually go for the time attack, right? Anyway, so then those are the more data capturing things. But then more into equipment, there's 3D printed shoes. The Chinese team actually had these printed for their boxing team. Apparently, it provides more protection for their athletes. Yeah, 3D printed shoes. Okay. And also, they also 3D printed custom made leotards for their gymnastic team as well. Apparently, it provides better protection as well.
Wait, plastic? Fabric?
I don't know.
Yeah. So I think and the reason why I asked this question is a lot of manufacturing methods are now starting to put the word 3D printing.
Yeah.
I mean, just to describe this like world we live in, which things are fabricated in the 3 dimensions.
Yeah.
I mean, clothing, 3 dimensions. And there's like 3D weaving technology that's coming out now in the manufacturing side, just automates clothing fabrication, which makes a lot of sense because a lot of it's done physically by hand. I don't know if you realize.
So is that still 3D printing then? 3D weaving?
Arguable. And that's the thing is that 3D printing for us in the industry, we know it as additive layers.
Yeah.
Usually with some kind of substrate. Mm-hmm. And like when you take traditional manufacturing and you automate it, is that 3D printing? I tend to not think so. Mm-hmm. But you can't argue for the fact that it's 3D fabrication.
Yeah.
And so like strings wound and woven into the final shape, like is that 3D printing? Material string
doesn't sound like it if we try to define it our way.
But I still think I know why industries
it's
are
being called.
Yeah, because you're getting a 3D object at the end of the day, but the methods of fabrication isn't how we describe 3D printing as, which is like layer upon layer upon layer. But you still get a 3-dimensional physical thing at the end.
So is this more like an evolution of the technology, or?
I think it's better to call it like 3D fabrication than it is 3D printing. But this is just I mean 3D printing is a key hype word a lot of industry and like companies use to bring attention to something.
Yeah.
And like 3D fabrication isn't quite mainstream of a term.
Uh-huh.
And so I think that what's happening is they're trying to get people to understand what they're doing while leveraging another term that is kind of close. That's okay.
Yeah.
And I mean, ultimately, at the end of the day, you have a 3D thing. Mm-hmm. But it isn't how like Adidas and like Nike is doing 3D printing, which is actually like 3D printing the way we know it.
Well, I guess it's for you guys to determine whether or not it's really part of 3D printing. And I'll also be putting up the screen and also a link downstairs to our article so you guys can read in depth about it.
Downstairs. But then down in the description.
Down in the description. So as Eugene was just saying about Nike, there was their very popular shoe called Vaporfly, and I'm not sure if everyone was in tune with the news, but it was banned last time.
In the last Olympics?
I believe, yeah. Because it was, I guess it was a bit too much.
Too good?
Too good, because the person that was wearing it, I think they beat everyone by quite a bit. Essentially what they have inside their shoe is carbon fiber plates squished in very highly compressed foam. So the explosive power received by the runner was crazy.
I suppose they deemed it as like cheating.
Yeah. And so now all shoes can only have one carbon fiber plate inside instead of 3. And
like a midsole.
Yeah.
Something that gives you structure.
To make it more what did they call it? Professional I guess to even the playing field. There was an actual term, but it's essentially to even the playing field amongst everyone.
That's a weird one.
Yeah.
I mean, the Olympics is something that is to test the physical abilities of people.
Yeah.
Or compete.
Yeah.
And a piece of technology, in this case a shoe, gives you an advantage of a couple of milliseconds, and that got banned. I suppose it's no different than taking like a physical enhancing drug and
Yeah.
being better.
Yeah. Which then I guess we can go on to the next topic, which is technology doping.
That's what they call it?
Yeah. They call it technology doping. So it's a controversial opinion between people. Having all these extra equipment and helping enhance the performance of the athletes, is it cheating?
Is it cheating?
Is it not cheating?
I mean, if that's the case, then there should just be standardized equipment, right?
Yeah.
Right? And like all the bikes should just all be the same.
Yeah.
All the shoes should be the same.
Yeah. Because if you look at it, there's disadvantage to athletes that don't have access to it, right?
Fair enough. Like how do I mean I don't I don't really know how the Olympics deals with it right now, but I'm assuming you can wear like your own favorite Nike shoe, assuming it doesn't have. So like, is that already happening to a certain degree?
I don't know.
Possibly, but I guess if the difference is like 4 seconds, maybe that's too much. If the article didn't exactly say how many seconds was shaved off. All these things. Technology doping is a great word to describe it, I guess. But like, if you had a steel frame bike versus a carbon fiber bike,
what the lightweight
kind of wins.
Yeah.
Right? So are there any rules against that right now? Like, I don't know.
I think your equipment needs to be approved by the Olympics before you can bring it in.
So like if I want to disadvantage myself, I could?
Yeah. I guess. Because I was reading something which we'll be talking about later. The bikes has to be available for sale to
the general public.
Before it can be approved by the Olympic Committee. So there is, I guess, something that you have to go through.
Right. Certification of sorts or
approved
like list of parts.
Before your equipment can be approved. Yeah.
I think it's kind of, I mean, that limits the one-off scenarios of like I wonder though, like we've heard of customizable parts made for specific athletes, right? And I think some of these things that we're going to cover does talk about that. So how does it deal with that? I guess we'll find out as we go through this list, but customizable grips or something like that. You can't buy those off the shelf.
You can,
And so if those are like, are the rules black and white? Are they a little gray?
Maybe it depends on what kind of equipment. Like a bike is a huge equipment, and while a grip is not.
But what about like a helmet that's aerodynamically optimized, if it exists? Or like a bike frame that is lightweight, but because of 3D printing, you have generative design that you lighten the bike by another 40%.
Perhaps some tools in the future should be standard, like amongst everything.
I think the Olympics should watch this video.
like as you said, the lightweight aerodynamic helmet, maybe everyone should get it.
Fair enough. I mean, if you look at in the past, like when the first Olympics first showed up, like the times were really bad.
Well,
I mean, and then like over the course of 100 plus years, I think it's been going on for that long. I don't exactly check.
I'm not sure.
It's been going on for a long time. Times have drastically gotten shorter and shorter for every category.
Yes.
And so like that, some of it is obviously physique, but there has to be some equipment in there that helped along the way.
Yeah.
Better shoes, better leotards or whatever it is, better grips.
Yeah. Well, I mean, not that we're dismissing the hard work of the Olympians,
the training,
the training, everything they put in, like it's their hard work, their sweat, their blood, their tears, and everything. No, we're not dismissing that, but we're just saying equipments.
Well, that's
are getting
and part of what we are covering is like 3D printing is pretty awesome, or advanced manufacturing in general is pretty awesome. Design philosophies behind generative design or optimization design, like all that is something that is super passionate that this team has here at Tinkering. And to see that kind of get like walled sucks.
Wow.
But I get it.
Yeah.
I do get it. Because you don't want to give one Olympian who is better funded, has better access to technology, all the necessary tool to be like 4 seconds faster just because of equipment alone.
Yeah.
Right? And that could break or make specific events, I suppose, or sports.
Yeah. Yeah.
Imagine badminton or something like that.
Well, having a lightweight racket, it's probably... Anyway, so we looked into Tokyo 2021 or 2020. They have a lot of 3D printed stuff. And one of the main thing is, I'm not sure if everyone noticed, the podiums are actually 3D printed. They are actually made from donated plastic, around 400,000 bottles of laundry detergent bottles. They reused that plastic, printed it, and then printed it out.
Right.
And then assembled the podium.
Is it little cubes or is it bigger? Like, is it like, it shows it as a single cube.
I think it's a little cube and then assembled together.
Like Lego.
Yeah.
That's pretty awesome.
Yeah.
I mean, great use of like upcycling in this case, plastic bottles recycled into, I think that's called upcycling. Yeah, it is upcycling. Or recycling and then like made it into a bigger thing. But like good on them.
Yeah.
Like, I mean, I also know that they did that with metals, but it wasn't 3D printed.
Yeah.
But that's pretty awesome. Sustainability.
Yeah, that's one of the big things that everyone saw. The more little things that you guys might not have noticed is the equipment. Some parts of the equipment. For example, like I believe the Italy cycling team, they employ 3D scanning and then printing for their handlebars. To make
That's not off the shelf.
Oh, I don't know how it gets approved, but they 3D printed it to make it more aerodynamic and fit for the Olympian.
Right.
And as a result, they won gold in the team pursuit and I think it was omnium, which is the you go around the track and then you gain points.
Interesting.
Yeah. So I'm not sure whether or not those actually contributed to their gold. But they did that, and this year their team has won.
Right.
So I guess that's one thing to think about. Another thing is for Great Britain, the team Great Britain, they had these new bikes that was in collaboration with Lotus. And they 3D printed end use parts for the bike, and from there they also won gold. And women's Madison and also men's Karen cycling. So
are these all cycling?
Yes. Well, no. And then we had a 3D printed rudder for the sailing team for Australia. Who won gold. And this one, they actually, in the article, it says because of the 3D printed rudder, they won gold.
I mean, we know 3D printing is pretty awesome.
Yeah.
But it seems like 3D printing plus something equals win gold.
Yeah.
And I'm pretty sure that's not the case. I'm pretty sure the athletes are just as important as all the equipment. But I think there's something to be said about this moment here because, like, one bike, one athlete, or like a couple bikes, a couple of athletes, super low production volume stuff, and super customized stuff, like 3D scanning on top of 3D printing, perfectly synergistic technology pairings. And you get this thing that is like comfortable, a lot more comfortable than standard, like off the shelf things.
It's made to fit. Your hand.
And whether or not the made to fit aspect actually enhanced it is a different scenario, right? It doesn't. Maybe it doesn't actually give you like 4 seconds of 4 seconds of like time shaven off while writing, but comfort is a big part of things, and I think that's where we see a lot of the medical industry going, custom fit things, one-offs, 3D printed,
like cast and everything.
like makes total sense.
Yeah.
And as materials get better, titanium, aluminum,
Stronger,
all that stuff.
lighter.
That's right.
Everything.
So this, no complaints.
I
Makes
mean,
sense.
as you talked about the comfort, the Korean teams, 3D printed custom grips for their archery. I mean, for their bow.
Right.
Men and women, they won gold.
Hey, did you know that in archery they don't actually grip the bow?
Oh.
It just pushes against the inside of the hand.
Well, if it completely cups your hand, then it's very comfortable.
Exactly. But yeah, customized, super low volume, great application for 3D printing.
Yeah. So those were just some examples. Whether or not there's a correlation with 3D printing and the gold, we will never know. But I'm guessing in the future, if there are more 3D printing technology that is incorporated into the tools or equipment, then I guess we kind of find out as time goes by.
You know, it'd be kind of cool to see like an Olympics where it's segregated, so standardized equipment.
Yeah.
And then like the exact same athletes with like enhanced gear to see just like how much time difference there be. Like I would be interested in that. I think it will work the athletes to death. Like we call it like the articles call it technology doping, but we don't actually have a basis to measure. I mean, unless the athletes do it twice, it's really hard to know. And then there's variables within like. One athlete doing it once versus doing it 3 times, and the fatigue that, like, I would love to know what the difference is.
Perhaps they do standardize first, and then from the fatigue, they have the equipment.
Yeah, but
then you can see whether or not they can actually maintain or is it faster?
I think they need to rest a couple days. But then again, there's a whole bunch of variables at play. Anyways. Moving on.
So other than the Olympics, there's also Paralympics, and for Paralympians, I guess it's even more important for them because standardized equipment, mass-produced, even for general athletes, it doesn't really fit them very much. So they need custom printing. And back then, I was reading this article. Just having for wheelchair racing, they actually need these gloves, which is the contact point for the wheels to turn. And back then, to make one was like a pair of gloves was like $250, and they have to do molding and everything for their hands. But then, for both hands because they didn't have the technology. And now, for them to actually have these pair of gloves that are made to fit is like printing it is like I believe in that video that I was watching was $4 per pair per hand, so that's $8. And also they don't have to keep changing or keep making a new mold because the digital data is actually stored inside the computer now.
Yeah.
And they can just reverse it for the other hand and it'll be perfect.
Really? They only do one?
Yeah, apparently.
I mean, makes sense.
Yeah.
There's actually a couple of industries that got changed this way.
Yeah.
The hearing aid industry got changed 100%. I mean, okay, not 100%, but it was like overnight that digital fabrication became the go-to production method. Because, I mean, everyone's intercanal is different.
Yeah.
And the process is also really invasive. You gotta
that's true.
plug in foam, extract it. But if you can do that once and then digitize it and then just make it multiple times over, patients get more comfort.
Yeah.
And the product is essentially the same.
Yeah.
Right. So I mean, this makes a lot of sense. I mean, $4, that's quite cheap. What material?
It ranged from a lot of different, and I know I was reading people have tested with PLA, PETG, the more special composite materials on
interesting.
And stuff like that. Which I was surprised about PLA.
Yeah, for those that don't know PLA or PETG, what we typically know as desktop 3D printing, the filament-based ones, thermoplastic, PLA is the most common of the plastics out there. For those that don't know what PLA is and all that stuff, we have a full course coming out on tinkering.com that talks about materials, common materials for FDM printer, and we're going to cover more. So if that's of interest, like I would check that out. But PLA is pretty strong. I mean, it's not heat resistance. That's the only thing that's kind of like, But maybe that's to their advantage because when they want to stop, like PLA gums up. I'm not quite sure.
I don't know, but it's essentially, even if it breaks,
$4 is
$4 is nothing, and for Paralympians that don't have support, that's great, right?
Yeah. I mean, especially if you want to talk about access to technology, FDM printing is so accessible right now. Like if we talk about like metal printing, aluminum, titanium, Inconel, stuff like that, that's maybe like 10% of people that have access. And then you also have to have access to it in the country and like whatever. But PLA, you can find that just like anywhere. And I'm pretty sure you have a print service somewhere near you that will offer you to print in PLA, PETG, ABS, and stuff like that.
Everything's pretty common now.
The only thing that they won't have is your digital data. So,
but then once you do it once, then they'll always have it in their archive. So
or you'll have it.
Or you'll have it. There was this Paralympian that has gloves that are used for training, exactly for training, which is softer, printed with a softer material, and then. When he does go for competitions, he does go for the harder ones.
Interesting.
Because apparently the harder gloves may injure yourself more just because of the movement and everything.
Wait, he went for the harder ones during competition? But it could injure him more?
Yes.
What's the advantage?
I don't know. But that's what I read. I will have to look back into it, but I'm guessing softer one is just used for training, more comfort, instead of not maximizing the
force output. That would make sense. I can see that. I can see that. I mean, it wouldn't surprise me if like, the ridges on FDM actually helps with like grip to a certain degree.
Probably. Right. I mean, traditionally you use rubber or anything like that. So, I don't know.
I mean, like all these examples that we're seeing, whether it be Nike or any of the the fabrications of these custom parts for these cycling teams that keep winning gold with 3D printing. It highlights one thing that's pretty key. Customizability. Right?
Comfort.
I mean, there's no way that these companies will set up a giant mold and die, injection mold one piece, just to have it cost $40,000.
That's like not cost effective at all.
Right? You know what? That's the exact same application as these rocket companies that are coming out and making unibody rockets. Because you couldn't do it any other way before. Or these like housing companies that are coming out. And disrupting the world with like press of a button, house come up in 24-hour type of situation.
Affordable housing.
Right? It's because there is no tooling. There's no upfront investment. You can like you as an athlete after 4 years, you can go on and do your thing. Another one can come in and we can do the same thing to you. Or to the next one. We couldn't do that before.
No.
Okay, not effectively and not cheap. Right? Or affordable. And one would argue if this is affordable. Because just because there's no die and tool up front, these things are still could potentially be hundreds of thousands of dollars. Like think about a bike frame printed out of titanium.
Just the material itself is pretty expensive.
That's not $20.
No.
The machine that can do that, it's probably a couple $1 million. Right? And so having access to that technology is already a barrier. And then materials on top of that will be another barrier. So, I mean, still, top of their class in terms of athletes, getting supported by their country and then the companies that are around them made this possible. The average person can't have access to that or won't be able to.
Olympians that don't have the backings of their country. But then, that being said, it also got shattered in this Olympics.
Fair enough.
There was a couple Olympians that won gold with no backing from the countries. So
sheer willpower.
And training and everything. So then, which moves us on to the last topic we have, which was the repair workshop that was at Tokyo Olympics, especially for Paralympics, and with all their equipment, their wheelchairs, their
Gear.
other gear.
Yeah.
The person that was supposed to be in charge of this actually mentioned that even though 3D printing is very handy right now, it's just not a plausible method they
For
use
production.
For production.
Yeah.
It's just takes too long to actually print out a repair piece. And they still actually ship like 4 containers of spare parts just to fix those equipment. Which makes sense. I mean, we know.
Yeah, that's the industry would call it the biggest weakness of 3D printing. And it is. Time to get product or part isn't 10 seconds.
Yeah.
It's sometimes 20 hours, depending on the complexity and size and all that stuff.
Yeah.
And even like a bracket or something that's like, I don't know, yay big. I don't know what yay big is. About 2 inches by 2 inches. Could take like 4 hours.
Yeah.
Right? And if something breaks and your competition is coming up in like 2 hours.
But then there's also the convenience of it. If I have my digital file for my custom grip, I can just send it in.
If you have enough time between when you need it to it breaking or when it breaks to when you need it, then absolutely it makes a lot of sense. And I can, like, technology tends to move towards faster deployment.
Yeah, I mean, it's still faster already, technically, because back then, production, you send in your designs and everything, you get a production back 2 weeks later.
Yeah.
And now you probably wait 48 hours.
But what if your competition is in like 4? I guess they just use a spare part.
Yeah.
Yeah. I can see the day, though, where like 3D printing is fast enough.
Yeah.
And it's like, oh, my wheelchair broke. Press a button. I mean, not quite the Star Trek replicator type of speed.
Yeah.
But come back in 30 minutes.
Yeah.
Yeah.
That's exactly what the guy that was responsible for the repair workshop said. Like, maybe in the future, instead of 4 containers of spare parts, they ship 1 container full of 3D printers.
Or I mean, if they knew which parts broke more often, they can just start printing those.
Yeah.
Logistics is expensive. I don't know if people realize COVID made logistics super expensive. And so if you can avoid shipping 4 containers worth of things in just 1 container with 3D printers and material.
Yeah.
Yeah.
Yeah, so as 3D printing technology, I guess, evolve, I'm guessing we're heading towards that direction where, like the guy said, it'll be 3D printers. Like he ships a 3D printer instead of 4 crates of repair parts.
You know what that's called?
What?
Just-in-time manufacturing. No, literally. And when people are sleeping, the machines keep working, and in the morning you have your part. That's, I think, the future we're headed to.
Yeah.
Injection molding and stuff like that will still exist because we need toothbrushes that are like $2 instead of $15.
Yeah.
And we need plastic forks, assuming plastic is here to stay, or whichever. There are certain things that we need massive volumes of.
Yes.
Right. And for anything that's complex, I see a pretty bright future for 3D printing and other advanced manufacturing technologies to take over.
Yeah. So the a lot to cover for Olympics, and we try to fit everything into this episode, but I guess this is the end of most of the things we're covering for Olympics.
Yeah.
So what do you guys actually think about this whole 3D printing technology and
technology
Olympics?
doping?
Yeah.
I would love to hear what you guys think about technology doping, because there's something fascinating about that aspect. If there's anything to be taken from the cycling teams show, potentially, what is to come. Or badminton teams or
any kind of team that uses
technology
to create custom pieces.
That world is coming. Okay, it's already here. It happened.
Yeah,
so it's already here.
Yeah.
Anyways.
So, I guess takeaway from this video is that, and think about it and leave us a comment below.
One thing I will say, we kind of talked about this at the beginning of the intro. We've been working hard on building out these courses about 3D printing, additive manufacturing, design that may be interesting for people that are interested in adopting this technology and or people that already have the technology that just wants a little bit more.
Yeah.
Right. Both intermediate, beginners, and advanced content will be coming out shortly. And we'll probably get back into a bit of a schedule for these TinkChat type of episodes where it's a little bit more casual.
Yeah.
So that we can reconnect with you guys and share with you guys kind of some of the thoughts that we've been thinking about industry evolving. Yeah. And there are some really exciting things happening lately in the 3D printing space. Like when I say 3D printing space, the corporate 3D printing space, companies acquiring companies and new devices and stuff like that. So like we want to get back into a bit of a schedule for that. But for now, I guess we'll leave you guys with this episode. Yeah. And if you guys want to check out some of the tinkering stuff that we've been building, go onto the website. Yeah. It's right there.
I'll leave a link in the description below. And always remember to press the bell button, subscribe to our channel for any latest episodes. And with that, I think it's a wrap.
Yep.
For this episode.
We'll see you guys next time.
Yep. Okay.
See ya.
Bye.